In this video, we are going to put together a couple graphs for exponential equations. So a quick brief, what we got going on here is exponential equations look like this, and B value is your multiplier. And so you have exponential growth if your B value is greater than 1. Graphically, it looks like this. Okay, so an exponential growth kind of starts off slow, but then it kind of shoots up over time. It does have what's called an asymptote. This is a line that if you go backwards, the graph approaches but never actually hits. Okay, so you have decay is another version of exponential, and that is when your B value is less than 1. Now we're not talking negatives. B will never be negative. So it's always positive. So growth is bigger than 1 when B is bigger than 1, and decay is when B is less than 1. And so visually, decay kind of levels off over time, kind of drops down quickly and then levels off. And again, it approaches this value, but never crosses it. So it approaches 0. So that is an asymptote. Okay, so this graph gets smaller. So it's a decay or a growth is you're gaining or losing a percentage. So if you keep on losing a percentage over time, you still always have something, no matter what. Like if you're cutting something in half, you cut it in half and cut it in half and cut it in half, you still always have something. So you can never technically get to 0 because half of something incredibly small is still something incredibly small. So so that's this idea that you're approaching a value that you never get to. So to graph one of these, we're going to do the first one kind of by hand, and then we'll show the calculator can help our cause here a little bit. So we're going to graph just by plugging in a bunch of numbers. Okay, so the idea is that our multiplier is 2. We don't have a number in the front. That would be an initial value, which is actually a 1. So there's a 1 snuck in there. So our initial value is 1, and then it's double. That's the idea. So we're going to plug in a couple negatives, a couple positives, and plot some points and kind of get an idea of what's happening. So let's start with 2 to the 0, and then 2 to the first, 2 to the second, 2 to the third. That'll help us kind of get a pattern. So then we do our negatives, 2 to the -1, 2 to the -2. It'll help us get an idea of what we're doing. So 2 to the 0, anything to the 0 is 1. That also represents our initial value. So our initial value of 0, we plug in 0, we get a 1. That is not a coincidence that it matches that value right there. When we do 2 to the first, that's 2. 2 to the second is 4. And we are doubling. That's the multiplier. 1 doubles to 2, 2 doubles to 4, 4 is going to double to 8. All right. So if we go backwards, we would be cutting this pattern in half. And so this would actually be a half. And the reason is that we are still taking 2 to the first power, but a negative exponent would have brought that first power down to the bottom. And then here, we're taking half of a half and we're getting a fourth. Reason is we're still squaring the 2, except the negative tells us that that's 2 squared should be in the denominator. So we're going to plot those points. So we have a 0, 1, we have a 1, 2, 2 is 4. Okay, so what we're doing is we're starting at a height of 1 and we are doubling the height every time. So now the height is 2, the height is 4, and then the height will be 3, or the third one, the height will be 8. And then if we go backwards, we're cutting it in half. So the height was 1, the height will be a half, and the height will be a 4, as best we can. So our graph, exponential, starts kind of leveling off like that. And we do approach this value that, see, it's that is our asymptote. We're getting back down to 0 and we'll never hit it. A couple of little details are some information is domain. domain represent your x's. What are the possible x's that we can plug into this equation? So is there anything that we can't take 2 to some power? Can we take 2 to positives, negatives? Yes. We can take 2 to fractions. You can take 2 to square roots. You can take 2 to pi, 2 to the pi. You can do, basically, you can replace x with anything, 2 to whatever power you want. So your x's, which are your inputs, we can plug in anything. There's no restriction. So we call that all real numbers. Okay, real numbers are fractions, decimals, pi, square roots, radicals, all sorts of things. Range are the values that we get out. So we kind of look at the visual on this. Your graph goes up forever, so all the y values going up, but not all the y values going down, because it doesn't go past the 0. In fact, it doesn't even include the 0. So your range are your y's, which are your outputs. So the values that we get out, we have a limitation to it. So your y values are going to be, as long as they're greater than 0, those are the ones we get. Okay, we don't actually hit 0, so I can't say y is greater than or equal to 0. We get infinitely close to 0, but not actually out. Okay, so the next one is we're going to do the same thing, but we're going to let the calculator kind of help our cause here a little bit. So I'm going to plot some points, x and y. I'm going to plug in, let's say, a -3, -2, -1, 0, 1, 2, 3. Okay, so similar to before, but I'm not going to do the math to figure this out. I'm going to let the calculator figure this out. So the calculator, and I'm going to do it a lot quicker than me just typing in a bunch of values. Shortcut version of this is I'm going to type in this equation into the calculator. So -2 to the x minus 3. And I'm going to look at the table. So the table is going to do the calculations for me. So I'm going to go back and get kind of the numbers that we're looking for. Oops. There we go. Perfect. So that's the calculator plugging it in and doing the math for me. So I get a negative 3.125, a negative 3.25, a negative 3.5, negative 4, negative 5, negative 7, and negative 11. All right, so I want to plot those points, see what it looks like, and then I could visually kind of get an idea what my domain and range is. So let's start with the 3. Negative 11 is not going to fit, so it's somewhere kind of off the grid here. So that's a 9, let's see, 10, 11. So right there. And then 2, -7 I can do. 2, -7, 1, -5, 0, -4. -1, -3.5. And then -3.25, -3.125. Okay, so there's our graph. So if I connect it, what's happening is our graph is really, really close to -3. And then kind of drops down. Okay, so what we got going on here is we do have a value that we approach and never hits, which is not ironically, it's actually in the equation, which is great. That value is our asymptote. Okay, so that is the value that we approach. Never hit. All right. And then our graph kind of starts off slow and then drops down fast. So that's actually a decay, not a decay, sorry. A decay levels off over time, where a growth, it kind of spreads away. So this is a growth. It's just growing into the negatives. So it's like debt. So your debt is getting worse and worse and worse because it's exponentially growing. All right, so our domain is our graph. There are no restrictions ever on an exponential plugging in values visually. That means I'm looking left and right. This graph goes left and right, slowly to the right, but it does go left and right forever. So we're looking at all real numbers. And that's actually always the case. And then our range is the graph does not go up and down forever. It does hit a high point. And we always describe range kind of as a, well, our Y values are going to be, we don't quite hit -3, but it's -3 and lower. So our Y values are going to be less than -3. We don't hit -3, so it's not equal to. All right, so that was just a quick ish kind of graphing some exponentials. The calculator can help your cause a little bit if you don't want to plug in a bunch of values, especially when the equations get a little bit more complicated.